Let's take an example of a simple bank account. You're writing a banking system where your program will be run in a ATM machine, right? So the way it will work is, let's see, we are creating an ATM machine or writing a Python program to operate ATM machine. So rather than writing a big, long, lengthy program, we'll think in small things. For example, when you open a bank account, you need an account. So let's see, account is an object. And now you will see that things are kind of connecting. Let's say account is an object. It's a logical object. It doesn't have to be a physical object like tree or car. It can be anything. So account is a logical object. And we know for sure that each account has an account holder name, right? We know the account has a number. We know that account has a type, like saving account or checking account, right? Each account has a type. Each account has a balance, like certain money the account has. Each account has a balance. So it has a name, the name of the account holder. It has a number. It has a type, which is savings or checking, and it has a balance. All these are the characteristics or nouns of the account that describe this account. If this account belongs to Pranay, it will be Pranay's name. Here, name of the account will be Pranay. Number may be 1, and type of could be checking account, and then balance may be $100 to begin with, right? If this account belongs to J, then J will have name equal to J. Number would be maybe 2, type would be maybe saving account, and initial amount may be $500, right? So this same account object can have different I wouldn't say form, but in real life, what we call it is instances. This one account is a generic program that represents account in general, but Pranay's account is a different object than J's account. So this number, it will be a string. This name, this will be maybe an int, because account number is always a whole number. This would be a type, which may be a string, right? And balance, it may be a double, because amount can be float, right? We already learned that. So in the memory, rather than the way, if you remember, I had taught you, rather than allocating individual ones, you always allocate one big block when you are dealing with an object. And within this, it's like a hotel inside a hotel, and where all your objects, now this is a name, it is a string, this is a number, this is an account number, and this is like number 10 account number. Then all these related 1, 2, 3, 4 properties all together always move together as a group. It's one object that represents, and this object belongs to Pranav. It's like, you see penthouses, when on a floor there are 4 penthouses. Within that, it's a whole house itself. It's a hotel itself. You have your master bedroom, you have you have kitchen, you have everything, but it's all complete suite. Similarly, JS will have its own suite, and you have inside, you have small memory. You never allocate one memory to one thing. Your whole block goes to one account, JS account, or So now you understand, like at a high level, what we are talking about when it comes to characteristics. Now let's say focus on some verbs, some functionality. So this account will have some functionality too. The account has a functionality, in fact, in real life too. The most common functionality in ATM when you go, right? You can talk to your dad or mom too. Functionality is check balance. You want to find out how much money I have. Check balance, right? You will have deposit money. Deposit is one functionality. There is withdraw. You want to withdraw money from ATM. The withdraw is another functionality. Check balance, withdraw. It's a change pin. Change pin, because each account also has a pin, right? Suppose these are 4 features. If you again notice, when you do check balance, what does it do? It goes and reads this value and returns it. It's a function that all it does is it reads and show you. When you withdraw money, what does it does? It goes and reduces the money here. The value from 500, if you withdraw $100, it will become $400. It changes, this functionality changes the balance here. If you deposit money, I put it here, check balance, right? If you deposit money, what happens is you are depositing money and it will become from $500, If you deposit $10 more, it will become $510. So as you can see, each of these functionality actually works on the data or the characteristics of that particular account. So this is how you start thinking in terms of account. You start thinking in terms of objects, different objects, and then you connect these pieces together. Suppose you're writing a banking system, you create an account object, and that account object is basically a program, Python program, that has its own data, it has its own functionality or functions, and it all becomes one unit. Similarly, you create another account, another object, and that may be, loan, you create another insurance. All these different blocks, different programs you created, but think you organize your program like an object. Everything is an object. And now, so suppose I want to, and I'll show you in the programming also how the measure the benefit is. So let's say when you're creating an account, right? So this account, again, let me quickly go back. Remember, I told you when you use functions, the major benefit of using a function is you are reusing the code. You write the function once and you can call it from multiple programs. The same benefit applies, but you get much more benefit because when you create an object, right, the object is self-sustained. The object also has data, not only functionality, not only the function, but data plus function both. Right? Advantage is now I can do better reuse of this functionality by creating a child object that will inherit all the functionality I have already defined. And how does this happen? Suppose I create an account. An account has, we understand that it has a name, it has an account number, suppose, and it has a balance. Let's keep only 3 for now. And then this account has functionality: deposit, withdraw, and deposit, withdraw, and check balance. These 3 things we already do, always do. Now, if I want to create a similar account, let's say I want to create a demat account, what we call it, like a stock market account, not really cash account, right? Then that account also has a name. Suppose I create an insurance account, that account also will have a name, account number, and balance. So rather than when I write, I may have a choice to write, this is my bank account. Then I'll create similar thing. I'll create insurance account. I may create something. All similar accounts I can create. And what I'm doing is I'm repeating this functionality again. I create saving account, checking account, loan account, mortgage account. All these accounts have similar features. So rather than creating individual and duplicating my code like this, the features, these features and the characteristics, I create one account and I extend this functionality and be more specific. Right? For example, in the loan account, you deposit, but you don't withdraw because you repay your loan, but you're not going to take more loan out of loan account. So you don't do that. So how about we find a common functionality, right, on an account? What are the common functionality? Like say account number, account name, and deposit. Suppose these 2 characteristics and deposit, these 3 are common between 2 different type of accounts I'm going to create. I'll just simply call this account, and then I'll create specific accounts. I'll say bank accounts or checking account. Let's call it checking account, check account, and I'll create loan account. Now I know that check account, this object, also has account number, also has name, and this also will have functionality deposit. Loan account will have the same thing. So how about if I find a way where I can take this account object, I created this object or this program once, and now I want to extend, I want to keep this functionality, but I don't want to recreate it here also. I don't want to recreate here also. I don't want to rewrite the same code again. Then it's duplicating the code. I wrote here 20 lines of code. I'm writing 20 lines here also. I'm writing 20 lines here also. It's a waste of time. So how about I find a way where I don't have to manually write these 20 lines of code again. I simply take away and tell Python that, hey, this checking account is going to be an extended version of my account. This loan account is going to be my extended version of my account object, but I'm going to add some more functionality. But all our functionality that account already has, just inherit it. Just make it available. You tell Python that take everything it has, plus I'm going to add some more. And that is how what we refer it as in object-oriented programming. There is one concept called inheritance. Using inheritance to extend the functionality of one program without duplicating the code, without writing the same code again. You take one program, the whole program, and extend it and add some more features. So it's like virtually you inherited and added. And if you look at real life examples, right, same thing happens. Like as I think in terms of humans, right, some of your characteristics, some of your features, you must have inherited either from your mom or from your dad, like color of your hair, or curly hair, or somebody has straight hair, right? You inherit it from your dad or from mom. Some of your characteristics, either you inherited from your dad or you inherited from your mom. The God did not every time create a brand new human. God has given this, the power in the nature that when you are born, everybody when is born inherits some of the characteristics. Like the child of a human will have two legs, two hands, hair, eyes, eyebrows, all of these features, right? You inherit from your dad, and your dad inherited from his dad. This whole concept of taking an object, extending it, and making some change is what we refer as inheritance. You inherit it, right? So like you think in terms of an account that has a common functionality between two different accounts you're going to use it. So create a common functionality and then extend that to virtually bring that functionality and add some few on top of it. For example, your eye color may not be exactly the way your dad or mom has. You may be a little bit different, right? You may be a little bit taller or shorter than your mom or your dad. You won't have exactly the same height. But that's the point. You inherit most, but you also have your own characteristics. And then again, your kid will have some of your features and functionality, but he or she may have its little bit different. And that is the whole concept of the parent and child, the copying the functionality, copying the code from one object to another object, one program to another program, so that you don't have to rewrite it. Idea is save time, make code more maintainable. Why more maintainable? Similar to functions, now you're not just writing a function, you are writing a program that can be extended to add more features on top of it. So that is what we refer as object-oriented programming. In object-oriented programming, how do you do that? You think in terms of objects. You write your base object, base program. When I say object, means you write your base program and you write it once and then customize it as you need it, little bit. That way, common functionality remains on the parent, and functionality that's different between loan account and checking account, make it specific to this. But majority of the functionality is same. So why not to write it once and extend it so that you don't have to rewrite the whole code again. That is what we refer as inheritance, and it's a concept of the concept of inheritance. And how do we reuse this whole program and extend the functionality is what we call it object-oriented programming. And in real life, people are using more and more of object-oriented programming rather than one lengthy program with all the functions and all that part. You still write functions, but this is an extended version of functions where you just not reuse the block of code, you are reusing the whole program itself. So suppose today I write checking account. Somebody can take this program and extend it and make it work for saving account too, because there is a lot of things that's common between checking account and saving account. Maybe a little bit of some difference,